Okay, we're talking about piecewise functions today. And what this means is that they're little pieces of functions. Like, for instance, this function is the part of this big one right here, which is the, which one? Absolute value. But if I take half of this and to get rid of it, and I say it was absolute value for the whole left side of the graph up until it hit this spot, and then it doesn't touch that spot. And then, with a different color, I'm going to make this side be like this and see if you recognize it. So on the right side of this function, it's x squared. And wherever they overlap is kind of the key moment. Who owns 0? Does the blue one or the red one? Nope, they don't both own it. You can't. And that's the most common mistake on the test. All it takes is for that endpoint to be screwed up. This one is owned by the red. And the reason there's an empty circle around it with blue is to show that the blue one goes right up to it, but then doesn't touch it. The red one owns 0, 0. Okay, so how do you write the equation for this? Well, it's half absolute value and half square root. So you just say this piece from negative infinity until it hits 0, it is the absolute value function. And from 0 to infinity, including the 0, it's the squared function. So you just say f of x is, and that's how you'd say it. It's absolute value from negative infinity to 0. And it's x squared from 0 to infinity. Get the idea? It's just parts. It's part this and it's part that. All right. I'd like you to see if you can graph one of these. You're going to need some graph paper to do that. If you don't, you know what? You probably don't have graph paper. So let me look. Oh, yeah, we got plenty of example problems. I'd like to work through some of the ones on your worksheet. So I'm going to pause for a moment while I hand out today's homework. Okay, look at number 1 in your homework. Usually they're going to give you the equations and you have to graph them. So in this one, they say that it's negative 1/2 x plus 6. All right, that seems like a scary equation, but it's really not that bad. Negative 1/2 x plus 6. And when is it that? Between 0 and 4. And then it's this equation, negative absolute value of x minus 6, between 4 and 9. All right. Where most kids are going to get this wrong, which number do you think they're going to screw up? Remember where I told you the most important part was? It's where the two functions meet. Where do they meet? At 4. Kids are going to screw up the 4 because they're not going to be careful with the details. All right, the 4 is the key point. Which one owns 4, the blue one or the red one? The red one owns 4. You could tell because it says or equal to 4. Okay, so the red one owns 4. All right, so now let's graph this guy, the red one. And how do I graph that? Well, don't forget, this is just the y-intercept and this is the slope. Remember that? So let's start at the y-intercept of 6. And don't worry if you graph too much of it. Just make sure you use pencil, because we can always erase part of it. Because you can graph, I mean, I'm going to graph a whole bunch of it. I'm going to graph a lot of it and then just erase it back to where it's supposed to be. It's only supposed to be this from 0 to 4. But if I go too far, it's all right. Do you remember the whole rise over run thing? This is a rise of negative 1. That means fall 1 and run 2. Fall 1 and run 2. This is a slope of negative 1/2. Okay, and now I've gone a little farther than I needed to try to make a point. This function would normally go on forever in both directions, but we are restricting its domain to only be good between 0 and 4. So it's almost like I'm putting up a big blocker right here at 0 to 4, and this is only good between those two lines. See what I'm saying? So it's only that function between here and here. All right. So get those lines out of there. There's the red part, or the first part of the function. Now remember I said that the key was the 4, where they overlap. Now, this one's an absolute value, so generally that's a V shape. It's only, oh, what? Somehow a plus 10 disappeared, huh? Okay, I'll put that in there. Do you mean like this? Okay, thank you. Okay, so how am I going to get these points? You remember that my thing that I said was your new best friend yesterday? XY chart. I would make an XY chart for this part. And what are the numbers I want? It even tells me right here. I should try 4, 5, 6, 7, 8, and 9. Okay, I don't have to even graph all of them. I'll start getting the idea. So I'm going to stick in 4 and see what happens for my little XY chart. If I stick in a 4 right here, sticking in a 4, what do I get? 4 minus 6. What's that? Negative 2, and then absolute value of that is 2. And then I make it negative again, so now it's negative 2. And then what? Plus the 10. What's negative 2 plus 10? 8. So 4 comma 8 is on my graph. I go over to 4, I go up 8, and now it's starting to get, this red one's in the way, so I'm going to get rid of him. I'm done with that one anyways. Okay, so 4 comma 8. Now this, like I said, this is really important. Right this second, I would get the problem wrong because I'm making it look like both functions own 4. And why is that not okay? Because then together they can't make a function because they're going to touch twice when I do this, the vertical line test. You know what I'm talking about? So that's the key moment, is where those two functions touch. So I'm going to make sure that that one right there, which one owns it again? The red one. So this one needs to have an empty spot right there at 4. And now I'm going to keep going with it. Well, it's a V shape, so basically I'm going to have a straight line going somewhere. I'll see where it goes. Yeah, I don't even really need to know. All I need to know is what number should I put in next. Well, I'm going between 4 and 9, so I'll put in a 5 next. Put in a 5. See what happens. 5 minus 6. What's 5 minus 6? Negative 1. Absolute value. 1, and then make it negative. Negative 1, and then add 10. 9. 5 comma 9. Over 5, up 9. There it is. You see where it's going to go now, probably? Probably going to keep going that way. Let's try another number, like say 6. If I put in a 6, I have a 6 right here. 6 minus 6 is 0, and it's all 0. Plus 10 makes 10. 6 comma 10. You see the pattern? 4, 8, 5, 9, 6, 10. It's going to keep going. All right, so over 6, up 10. There we go. Now, I have only done 4, 5, and 6. I'm hitting the edge of my graph here. But how far should I go? I should keep going until I hit 9. All right, so I technically am supposed to go to here, but I can't because my graph doesn't have enough dots on it. But basically, this line would go up farther this way until I finally meet up with this spot right there. Okay, do you have room on your graph either? So you can just stop right there. Okay, you've graphed your first piecewise function. It's got one piece of this and it's got one piece of that. And where they overlap is the key moment. And that's, this one's got an empty spot on the end of it, and this one's got a solid dot because the red one owns the 4. Yes?
So they might not actually look like they overlap, but it's
They don't actually touch each other. No.
And then is the y point going to be the same, or is the x one ever going to be?
If the x numbers, I don't know what you mean by that.
Like this one, they share.
How about this? It'll always pass the vertical line test. So you'll never have them overlapping each other like that, if that's what you mean. Yes? Yeah, it is part of a V, but where does the V turn? Okay, so it's not going to turn while we're doing it, but maybe so like the V, I don't even need to know, but let's say the V, it goes like this and it goes like that. Okay, I only have part of this graph though. I only have the part that's right in there. So it might be making a V. Maybe it'll go down later. It'll start coming down or something. But anyway, and it will eventually, but it doesn't happen during the part of the graph that I care about. Okay, let's try another one. Let's do number 2 together. Unless you guys are already done with number 2 and want help with number 3 or something.
How do you know what numbers to put in?
2? All right. Okay. Well, because it tells you it's between 4 and 9, so that would be the logical numbers to put on the chart, because it says it's only good between 4 and 9. Okay, moving on to number 2. number 2. Then I'm going to pull up a graph for that. Okay. All right. And it says that it is 2x, or negative 2x minus 1 between negative 2 and 1. Less than or equal to 1. And then it's negative, I'll use a different color. I'm going to click over here somewhere, thank you. Negative, parentheses, x minus 3 squared plus 5. And it's that when x is greater than 1. Okay, so this graph is a Frankenstein. It's got 2 parts. I'm going to graph the green part first, and that is just a line that has a slope of negative 2 and it has a y-intercept of negative 1. I hope you know to start here. And then how do you do this negative 2 thing? You put it over 1, and then you say fall 2, it's a rise over run, except in this case the rise is negative. So fall 2, and then run 1. So there. And I keep going with that pattern. Okay. And then I got to look back at the end when I'm done with this thing and try to figure out, like, where am I supposed to be going between negative 2 and positive 1. Okay? So I should keep going with my pattern this way a little bit. And it goes between, think of these things as you know, x is negative 2 is like a barrier here. It only goes between here and here. That's the only place I want to have this function. So I don't care what happens to it outside of that little zone. Only between here and here. Okay. Then the other function, the red one, works anything bigger than 1. And I was telling you the key point is going to be where they overlap. And you got to be really careful with that spot. Make sure you know which one owns it. 1 is the key spot this time, and the green one owns it. So I'm going to have a darken in dot right there at x is 1. See if I follow it down there? Okay. Now, on the other one, I'm going to do an xy chart again for this red one. X, y. I'm going to stick in some numbers for x. It says x is bigger than 1, so I'm going to put in 1. 1. If I put a 1 right here, 1 minus 3 is negative 2. Negative 2 squared is 4. Negative makes that negative. Negative 4 plus 5 is 1. 1 comma 1. But can I put a normal dot right here? No, and that's where kids will get it wrong because they'll not notice that now the thing won't pass the vertical line test. So you put an empty spot right there because the black function I'm making here does not own that point. The green function did. Because one will say is equal to 1, and this one says it's bigger than 1. The one that says that it's equal to 1 owns the 1. Okay, and now if I keep going, I'm going to put in some numbers bigger than 1, like 2 and maybe 3. So I'm going to stick in x is 2 now. 2 minus 3 makes negative 1. Negative 1 squared is 1. Make that negative. Negative 1 plus 5 is 4. 2 comma 4. Over 2, up 4. Okay, and this is a parabola, so it's it would be really hard to freehand. So that's why doing these points is smart. I'm going to put in a 3 now. 3 minus 3 is 0. 0 squared is 0. Make that negative. It's still 0. 0 plus 5 is 5. 3 comma 5. Okay, I'm going to keep going with my point system. I'm going to go with 4 because this is starting to turn. 4 minus 3 is 1. 1 squared is 1. Make that negative. Negative 1. Negative 1 plus 5 is 4. 4, 4. Look at that. It finally turned the corner. And what shape is this anyway that I'm graphing? It's a parabola. Good. Now, should I keep going forever? Yeah, you pretty much should. You should keep going all the way to the edge of your graph paper. When it says to go to infinity, we expect you to know you shouldn't just stop here, for instance. Why stop here? You got to keep going to the edge of the graph paper. So I just have to put in a couple more numbers and it's going to go off my graph paper. So after 4, 4, I'm going to continue my little chart up here and try 5. If I put in a 5. This spot's getting kind of messy here. Putting in a, oh boy, undo, undo. Get that 1 out of there. Okay, putting in a 5. 5 minus 3 is 2. 2 squared is 4. 4 plus 5 is 9. 5 comma 9. Look at that. I'm right to the edge of my graph. Did I do something wrong there? I'm going to try that again. Put in positive 5. 5 minus... Oh, there's a negative in front of this whole thing. Sorry, I'd erased that at some point by accident. Okay. 5 minus 3 is 2. 2 squared is 4, and that's a negative 4 plus 5, which would make a 1. 5 comma 1. So I go to 5 comma 1, and I put a dot there. And now I'm going to put in another point. 6. 6 minus 3 is 3. 3 squared is 9. Make it negative 9. Negative 9 plus 5 is negative 4. 6 comma negative 1, 2, 3, 4. Getting close. I bet the next one goes off the page. 7. 7 minus 3 is 4. 4 squared is 16. 16, make it negative. Negative 16 plus 5 would make negative 11. So yeah, it's off the page. So I'm done. I don't have to keep going down there. All right. So I connect the dots. There. That is a piecewise function. It's got two pieces. It's got the green part, and it's got the red part, which I graphed with black. And the key moment is where they overlap. And that's where I almost always have to mark them wrong, is if a kid is screwed up where that is. Just make sure when it's done, it passes the vertical line test, and then you'll realize, oh, wait a minute, only one of these things can work, because if you had made it solid right here, you would be failing the vertical line test. Yes, if you make a little circle, it means that it's an empty spot. It means that it's not touching right there. Yes. If they ever crossed, they wouldn't be passing the vertical line test. Okay. You getting the idea? All right. Well, you've got a lot here, and in fact, for a Halloween night, it's too many. So let's cut out some. I'd say... it feels like you could probably skip 7, 8, and 9. Those are all probably unnecessary. Why don't you just do the one sheet? Why don't you tear off this other sheet, 7, 8, 9, and then save it as graph paper, like stuff it in a folder somewhere. So when I say, hey, you need some graph paper, use this. Okay? All right, let's talk about number 3. Okay, number 3. Somebody made a good point that that's a really weird function, but it's still a function. Okay, I'm going to drag one of these out here. Number 3. And the function says, for number 3, that you're supposed to be negative 2. How is a function, f of x, equal to negative 2? Well, remember, what's f of x the same as? Y. So that's really y equals negative 2. So that's really a line at negative 2, like this. That's negative 2. That's graphing negative 2. That would be graphing all of negative 2. But is all of negative 2 what we want? No. We want it to be negative 2 up until it hits negative 2. That's a little weird. So it's only up to here. So there. That red part of the line, that is my f of x equals negative 2. It's only negative 2 when x is less than negative 2. So here's x, remember. Okay. Okay, so then the endpoints are key. Does it own negative 2? No, the next function does. The next function is, it's the absolute value of x between negative 2 and 3. So between negative 2 and 3, that's between here and here, I got to draw the absolute value function. Well, I remember what the absolute value function looks like. It's a V shape, and it goes like this. So I don't even have to do all that plugging in points and stuff. I missed it kind of on the right there. Might have been better off to make an XY chart, but there. Okay, I've made my V shape between there and there. Now, why would I get this wrong on the test? Because right now they both own the point negative 2. and they can't. So I have to have an empty circle here to make it clear. This one doesn't own negative 2. The blue one owns negative 2. Okay, and I did it up to 3, and that was good. And it owns 3 because it says or equal to 3 there. So I'm going to put a darkened circle in there. And this got 3 parts. So then the third part is y equals negative 1/2 x. You got to go back old school and remember what these mean. This is a y-intercept of 0. I threw in a plus 0 to help you see that. Y-intercept is 0, and it's got a slope of negative 1/2. What? It doesn't own 3?
The absolute value does not own 3.
Oh, let me double check what you're saying. You are right. I'm sorry. That is not an or equal to sign right there. So that does not own 3, and so I'm going to put an empty circle at 3. Thank you. And see, I told you those are the spots everybody makes mistakes. Even the teacher just made the mistake right there. Because I couldn't read my board, but yeah. Anyway, those are the common places to screw up. All right, this last part, I'm having a hard time visualizing where this graph is, so break out the XY chart. XY chart comes to save the day again. And what should I use it for? I'm going to plug in some points into this equation right here and find out where I should go with it. It says x is bigger than or equal to 3. So it's this blue equation when x is greater than or equal to 3. So starting at 3, I'm going to stick a 3 in my chart here and see what happens. Put a 3 right there. Negative 1/2 times 3 makes negative 3/2, which is the same as negative 1.5. Negative 1.5. If you wanted to say negative 3/2, that'd be fine. But it's easier for me to use decimals sometimes. So I'm going to go with 3, comma, there's a point at 3, comma, negative 1.5. 3, comma, negative 1.5, right there. And then I'm going to try another couple points. And it is a straight line. I know it's that because it doesn't have a squared in it. It doesn't have a square root in it, so it's a straight line. So I just got to figure out what the next couple points are, and it'll tell me where the straight line goes. All right, so then I'm going to stick in a 4. Take this 3 out of here and put in a 4. And if I put a 4 right here, negative 1/2 times 4 would be negative 2. Negative 2. There, negative 2. That's it. 4, comma, negative 2. 4, comma, negative 2 is right there. I think I see what's going on here. I'm going to put in 6 next, just to show you don't have to do every single number. I'm going to put in 6. I'll put a 6 right here. Negative 1/2 times 6 would be negative 3. Negative 3. So 6, comma, negative 3. There we go. Those all lining up in a straight line? Yes, they are. And I'm going to keep going like that all the way off the edge of the page. Because it said it didn't ever give you an ending point. So you just follow all the way to the edge of the page. All right. I've done 3 of your homework problems for you, and there's only 6. So I think you got the idea on piecewise. Now what we have to talk about, unfortunately, we're not done. Last night I had skipped 2 problems. They are crucial. They are things we expect you to know for tests. So take out last night's homework if you haven't already got that out, and turn it to the back page. And let me teach you one last thing about that. When you are given a strange shape and then they ask you to take an absolute value of that function, you need to know what to do with it. So if I'm going to give you one for example, let's say that I gave you this. I don't like this. I like to keep my numbers even, so I'm going to go like this. There, and then let's make it go like this, and then down like that. Okay, there is a strange shape. If I take my strange shape and I do the absolute value of it, the blue one is f of x. What if they ask me for f of, and there's 2 places I could do the absolute value. I could absolute value the x, or I could do like this green one and do f of x, but put the absolute value around the whole thing. Okay, got to know the difference between the 2. The red one, where they're absolute valuing the x, that's the harder of the 2. I'm going to teach you the green one first, where you're absolute valuing the f of x. Remember how I keep saying f of x is the same thing as y? Right? So the f of x is like y. So isn't this exactly like the absolute valued the y's? Where are the y's on here? That's the up and down, right? If you absolute value the y's, do you get that the positive numbers won't change at all? If you absolute value a positive number, it doesn't even change. So the only thing that will change is any negative y's. When you're absolute valuing on the outside, you're taking any y's that were negative and making them positive. So see how this was at -2 right here? That's going to go up to +2 right here. So your graph stays exactly the same all in here because all the y's are positive in there, all the way till there. And then it switches, and just this little part right here changes to this. So my new graph looks like the red one there. Only thing that was different is the part I circled there. Because we absolute valued the f of x, and the f of x is like the y's, I absolute valued the y's. Any place there was a negative y, and the only place there was a negative y is right in here, those have to change to positive numbers. And what that means is they basically reflect up. So your final answer would be the red shape that's right over the top of the blue one. It's all the same in here. This part right here is all the same till right there. And instead of going down right there, it has to go up. Okay, that's the easier of the two. You just take anything that's negative in the y's, reflect it up. Done. So I'm going to give you another one like that. So let's say I had a different shape. Let's say it looked like this. Then, do you get, if I do the absolute value around the outside of it, all I got to do is take anything that's in the negative y area, and instead of going down here, I'm going to go up like this, and up like this. So my final answer would be that part stays the same, and these parts go up. And I'd erase this. There. The original, again, looked like that. Raise your hand if you get that kind. Okay, good. Now the harder kind. Let's say I had the same exact shape. No, new shape. I'm going to make a turtle. So okay, there's my turtle. He's got a funny looking beak here. Here's his shell. Racing stripes on the side. Okay, anyway, there's my turtle, and I'm going to take my turtle and do the absolute value on the inside now. So I'm going to go, instead of f of x, I want f of absolute value of x. Now, I have to find where my x's were negative. Last time I was down in here, because this is where the y's are negative, right? Now I'm doing where the x's are negative. Do you see where the x's are negative? Do you get that it's in this zone that I'm messing with now? All right, and this kind is kind of easier in the way than the other kind. If you just remember this, you completely wipe out what's in that zone where the x's are negative. Because do you get, if you make an absolute value on all the x's, they can't be negative anymore? They're going to be gone. You just simply erase them. They're gone. And what do you replace them with? A reflection of that side. It makes the Minnetonka M. There's your final answer. You erase all the things that were negative x's because they can't be down there anymore. Now it's absolute valued. And then why did I reflect that over? The reason I reflected that over is, do you get right now that if I put in a 1, that the function tells me the answer should be positive 1. If you put in 1 for x, that it'll tell you 1 for y. 1 comma 1. Do you get that 1 comma 1 was a point on my original shape? Then if I put in a positive 1, it tells me, oh, the answer is positive 1. When you do absolute value like this on the x, what it means is if I put in a negative 1 for x, it thinks I put in a positive 1 for x. Because I put in a negative, but I absolute value it, it's just like I put in a positive. That means the stuff on the right-hand side is going to reappear over here. Anytime I put in a negative 1, it's just like I put in a positive 1. It says the answer is 1. When I put in a 0, it stays exactly the same. When I put in a -2, it thinks I put in +2. And it says, oh, well, the answer for that is -1. So when I put in a -2, it says -1. See? Now, I tried to explain it to you, and some of you are not, some of you probably got that. Some of you probably don't have any idea what I'm talking about. And for you, I'll give you the really simple recipe. Okay? I'm going to summarize on a new one. So if I give you a shape, and it looks like this, and I'll make a new pointy thing that goes down like that. Okay? If I have this kind of a problem, and then they give me absolute value of the inside, I would find where the x's are negative and make them go away, because they can't be that way anymore because they're absolute valued. See how I erase all that whole side? And then do you remember what to do with to reflect it over? Yep. You just have to reflect it over. So I'm going to find where 3, -2 is, so I go to -3, -2. There we go, and it just kind of goes like that. You erase the left side and reflect stuff over. All right. Those are important. We will review those tomorrow, but you'll need to know those. Any other questions for right now on that? All right. I think your brain's probably got enough. I'll answer individual questions later. And that's all the lesson I have for today.